Good day, everyone. Welcome to this session on project quality planning, an essential process within projects management that plays a critical role in determining whether a project will deliver outcomes that are acceptable, sustainable, and valuable to stakeholders. Now, project quality planning is part of project quality management knowledge area as outlined in the Project Management Book of Knowledge Guide. So, this objective of this process is to identify quality requirements and standards for the projects and its deliverables and to document how the projects will demonstrate compliance with those standards. In many projects, quality issues trend appear near the end, often when they are the most costly to fix and most disruptive to project success. Now, this is why quality must be addressed from the beginning, not as a reaction to problems that arise later. Defining quality in the PMBOK context is the context of project management. Quality is defined as a degree to which a set of inherent characteristics fulfills requirements. It is not about creating luxury or perfection. It is about ensuring that the project deliverables are fit for purpose and conform to agreed specifications. A low-cost public housing project, for example, can be high quality if it meets safety codes, is durable, and satisfies the needs of its occupants. Now, likewise, a software application can be high quality if it runs reliably, performs well under load, and meets user requirements, even if it's not feature heavy. Now, according to the PMBOK guide, the three main processes within the quality management knowledge areas are: number one is plant quality management, manage quality and control quality. So in this session, we will focus on the first of these, plant quality management, which sets for the foundation of quality will be achieved and measured throughout the project. Now, inputs to quality planning. So the plant quality management process requires a number of inputs to be effective. According to PMBOK, these inputs include the project charter, which outlines the high-level goals of the project, the project management plan, especially the scope, schedule, and cost baselines, the stakeholder register, which helps identify who defines quality and whose expectation must be met, the requirements documentation, which includes both functional and non-functional requirements. Now, enterprise environmental factors such as legal regulations, industry standards, and cultural conditions. Organizational process assets such as templates, past project reports, and quality standards from previous works. For example, if you are managing an automated warehouse installation project, your quality planning inputs might include ISO 9001 standards, government safety requirements, performance expectations for system throughout, and lessons learned from past automation failures. So these inputs help shape a quality plan that is tailored, realistic, and aligned with stakeholder needs. The tools and techniques of quality plan. The PMBOK guide also outlines a number of tools and techniques used during quality planning. So these includes the cost-benefit analysis, which assesses whether the cost of implementing a specific quality activity justifies the expected benefits. The cost of quality, which includes prevention costs, appraisal costs, internal failure costs, and external failure costs. Now, these allows you to understand the total cost of achieving and not achieving quality. Benchmarking, which involves comparing your project practices with those from similar projects and recognized industry leaders. Design of experiments, a statistical approach to identify which factors have the most influence on the process or product outcome. Expert judgment and meetings, which partner insights, which get insights from those with experience of technical expertise in quality-related areas. For instance, in a cloud migration project within an IT organizations, you might use benchmarking to compare cloud service providers in terms of availability, scalability, and security. A cost-benefit analysis might help you decide whether a second layer of encryption is worth the additional processing time and infrastructure cost. The outputs of the quality planning process, the plant quality management process, results in several key outputs, namely the quality management plan, which details how quality will be managed and assured during the project. It includes quality rules, standards, procedures, and audit schedules. Quality metrics, which are specific, measurable standards used to evaluate deliverables. Examples might include uptime percentage, defect rates, or cycle times. Now, quality checklists which ensure that each activity or deliverables is reviewed against predefined criteria. Now, a process improvement plan which outlines how project processes will be evaluated and improved throughout the project life cycles. Consider a residential high-rise construction project. The quality metrics may include concrete strength, plumb tolerance, and waterproofing performance. The quality checklist would guide daily inspections on site. The process improvement plan might introduce more frequent quality audits or the use of new materials to prevent reworks. Now, these outputs are not just for documentation. Now, they are practical tools that help team deliver value efficiently and consistently. Applications in construction, IT, and manufacturing. Now, let us now look at how project quality planning is applied different industries. In constructions, particularly in infrastructure projects such as highway expansions, the quality must account for compliance with national regulations such as Malaysia's JKR standards. So the quality requirements might involve soil compaction values, asphalt thickness, and structural integrity. In IT projects, such as implementing a learning management system for a university, the quality plan may focus on the system performance, data security, compliance under PDPA regulations, and user interface testing for student satisfaction. Now, in manufacturing, especially in electronics, a quality plan is crucial for control variables like temperature, humidity, and electrostatic discharge in clean room environments. Quality metrics could involve defect rates per batch for the accuracy of soldering processes. Now, these examples show that while the details differ, the principles of quality planning are universally applicable. Now, stakeholder engagement in quality planning, one of the most important aspects of quality planning is ensuring alignment with stakeholders' expectations. It is critical to involve key stakeholders early in the planning process to understand their definition of acceptable quality. For instance, in a smart city project, stakeholders may include government agencies, citizens, utilities providers, and technology vendors. So some may prioritize efficiency, innovation, while others focus on the sustainability and data privacy. Failure to align to these expectations can result in dissatisfaction, rework, or even project rejection. Now, engagement activities may also include workshops to define quality expectations, mock-ups or prototypes for stakeholders' reviews, the surveys to capture user perspective, early quality gates for inspection and feedback. By integrating stakeholder inputs, the quality plan becomes more robust and achievable. Now, consequences of inadequate quality planning. When quality planning is overlooked, the consequences can be severe. One example occurred in 2018 when a major airline experienced a global check-in system failure on the day of the launch. Flights were delayed, passengers were stranded, and the company suffered reputational damage. An internal investigation revealed inadequate quality planning, including incomplete testing and no contingency measures. Similarly, in Malaysia, several affordable housing projects faced delays due to quality non-conformance, such as structural leaks and poor workmanship. Now, these issues could have been prevented with stronger quality planning, clearer metrics, and better contractor oversight. Now, these cases show that poor quality planning leads not only to cost overruns and delays, but also to long-term loss of trust and credibility. Building quality from the start. In conclusion, project quality planning is not merely a process, but it is a mindset that prioritizes prevention over correction. It ensures that the project is built on the foundation of clearly defined standards, stakeholders alignment, and continuous improvements. Now, as project managers, we must remember that quality is not just the responsibility of inspectors at the end of our projects. It begins at the very start with thoughtful planning, open communications, and rigorous documentation. Thank you for joining today's session, and I hope this discussion has enhanced your understandings of how to plan for quality in your project so that when you deliver, it's not only complete on time, but truly fit for purpose.